All right, the last section of this chapter is section 7.5. This is using the Pythagorean theorem. So earlier in the chapter, we learned how to solve problems with the Pythagorean theorem, and now we're going to kind of use the converse of the Pythagorean theorem, which says if a squared plus b squared is equal to c squared, if that's true, then the triangle is a right triangle. Okay, so we're trying to prove whether a squared plus b squared really is equal to c squared. Okay, sounds kind of confusing, but it'll make sense in an example problem. So basically, I don't tell you that it's a right triangle. You have to use the Pythagorean theorem to determine it, okay? But still, the longest side is going to be C. That's the biggest thing you need to remember. Okay, so the longest side here is 41, and then A and B really doesn't matter. So that's going to be A, and that's going to be B. Okay, so the Pythagorean theorem is A squared plus B squared is equal to C squared. Okay, and A squared plus 40 squared is equal to 41 squared. This is 81. 40 squared is 1600, I believe, but let me get my calculator out. 1600. And then 41 squared is 1681. So now I need to evaluate a squared plus b squared, and I have 1681 is equal to 1681. So yes, this is a right triangle. It is a right triangle. Okay, so let's look at this. The longest side here is 24, so this is going to be C, and then B and A. Once again, A and B don't matter. So I'm still using a squared plus b squared is equal to c squared. Now you cannot just assume this is not a right triangle just by looking at it. You must prove it to me using the Pythagorean theorem. Okay, so this is 12 squared plus 18 squared is equal to 24 squared. 12 squared is 144. 18 squared is 324. And 24 squared is 576. Okay, so then I add 144 and 324, and I get 468. And since 468 is not equal to 576, this is not a right triangle. So that is the converse of the Pythagorean theorem. You plug in the three sides and see if a squared plus b squared really is equal to c squared. If it is, it's a right triangle, and if it's not a right triangle. All right, try these on your own. Biggest thing to take away is the longest side is equal to c. Okay, so pause these, press play when you have completed both of them, and we'll see if you got your answers right. All right, I went ahead and wrote number 1 out while I was paused so that I didn't waste time. But this one was pretty easy. C is 28 because that's the longest side, so a squared plus b squared is equal to c squared. 441 plus 400 is 841. That is not equal to 784. Therefore, this is not an example of a right triangle. Question 2, I'm going to do this one with you. 1.25 is the longest, so this is C. And then these don't matter. I'll make this A and make this B. Okay, so I have a squared plus b squared. You'll notice I write the formula every time. This is a great habit to get into so you don't mess anything up. 0.75 squared is equal to 1.25 squared. Okay, 1 squared is 1. 0.75 squared is 0.5625. And then 1.25 squared is 1.5625. Okay, so when you add these two together, you get 1.5625, and this is equal, obviously, to 1.5625. So yes, this is a right triangle, because a squared plus b squared is indeed equal to c squared. Right, second part of this chapter is called the distance formula. Okay, so when they do not give you the length of each side, they just give you the coordinates. You have to use the distance formula, which looks scary, but it's not too bad, which is right here. Okay, so the distance between any 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. You will not have to have this memorized. I will provide this formula for you on a test or a quiz. Okay, so basically it just gives you the distance between the 2 points. So finding the distance, we are going to call this x1 and y1, and this x2 and y2. And the distance formula, you need to write it out every time, is x2 minus x1 squared plus y2 minus y1 squared. It kind of looks like the slope formula with the x2 and y2 and stuff like that. Okay, so when I plug in the numbers, it is the square root of x2, which is negative 4. So negative 4 minus x1, which is 1, squared, plus y2 is negative 2 minus y1, which is 5, and you have to square that as well. Okay, you'll notice that I like to write it out each step, but I don't get anything confused. So this is negative 5 squared plus negative 7 squared. So negative 5 squared is 25. Negative 7 squared is 49. So now I have the square root of 25 plus 49. And I do that in my calculator. I get distance is equal, oops, go back. The distance is equal to the square root of 74. And if I do that in my calculator, actually you don't even have to turn it into a decimal. You just leave it as the square root of 74. Okay, example 3. This is a kind of a lengthy problem, so bear with me. Okay. Okay, so my football play is starting at, I'll erase this. My play is starting at the start and running this first distance and running the second distance to the end zone. Okay, so basically what I need to find is distance 1, distance 2, and distance 3 to prove whether or not it is actually a 90-degree turn or a right angle. Okay, so the first thing we need to find is distance 1. And for distance 1, it's going to be equal to, remember, x2 minus x1 squared plus y2 minus y1 squared. Okay, and at this point, if I'm finding the distance of 1, I'm focusing on this space. Let me get a different color. This space right here. Okay, so this would be x1, y1, and this would be x2, y2. Okay, and so that would be x2 is 30 minus x1 is 60 squared plus y2 is 20 minus 50 squared, which gives me 30 minus 60 is negative 30 squared, plus 20 minus 50 is negative 30 squared. So 30 squared, I'm going to write it over here so I save some room. So this is equal to the square root of 30 squared plus 30 squared, which is the square root of 1800. Okay, so I'm going to leave it as the square root of 1800. I'm not going to simplify it anymore because it's not a perfect square. Now I need to find the distance of 2. It's the same formula up here. I'm not going to rewrite it again just to save space. Okay, but I'm finding D2. So now I can keep this as y2, x2 and y2, and now this is going to be x1 and y1. So distance 2 is x2, which is 30, minus x1, which is 80, all of that squared, plus y2, which is 20, minus a negative 30, which is really the same thing as plus 30 squared. Okay, so 30 minus 80 is negative 50 squared, plus 20 plus 30 is 50 squared. Okay, so this is going to be 50 squared plus 50 squared is the square root of 5,000. Okay, in D3, you're running out of room, but D3 is right here. Okay, so you're using this set of points and this set of points. Okay, it really doesn't matter which one is x1 and y1 and which one is x2 and y2 because when you square them, it's always going to be the same number. Okay, so Oops, go back. I'm going to keep this as x1 and y1 and change this to x2 and y2. Okay, honestly, it really doesn't matter whatever way you choose. So the distance of 3 is going to be x2, which is 80, minus x1, which is 60, all of that squared, plus y2, which is negative 30, minus y1, which is 50, and all of that squared. Okay, that's going to give me 80 minus 60 is 20 squared, plus negative 30 minus 50 is negative 80 squared, which gives me the square root of 6,800. Okay, I'm going to go to a new slide because things are getting a little crazy. So distance 1 is the square root of 1,800. Distance 2 is the square root of 5,000. And distance 3 is the square root of 68,000. Okay, so now I need to see whether a squared plus b squared is equal to c squared. And these are my distances. Once again, this is the biggest, so this is going to be c, and then a and b doesn't matter. So I have the square root of 1,800 squared plus the square root of 5,000 squared, and I'm trying to see if that is equal to the square root of 6,800 squared. Okay, you guys realize if I take the square root of something and then square it, the number itself is just left. So the square root of 1,800 squared is just 1,800, which makes this 5,000, which makes this 6,800. Okay, so I add these two together. I get 6,800 is equal to 6,800. So yes, to answer this question, he made a 90-degree turn. A very complicated question, but hopefully it challenged you a little bit. You have 3 more on your own problems to do, A, B, and C. Hit pause. Since I'm kind of running short on time, I'm just going to have them worked out again when you hit play, and you can check your answers that way. Give me a second. All right, here are the answers to A. A is the square root of 41, B is the square root of 85, and C is the square root of 25. And since that is a perfect square, you can write it as D is equal to 5. But the only way you write it as the only way you get rid of the square root is when it's a perfect square. And that's it. I'll see you tomorrow.